Sit down.
Okay, so an alcohol group is any time I take a large chain of carbons like this. We can take butane, for instance, and add an OH to it in place of one of the hydrogens. And instead of butane, this now becomes butanol. Okay? And you'll see a lot of things in your life that have the ending OL. Okay? And like you go to the store and buy some rubbing alcohol, it says isopropyl alcohol. But even anything like this, butanol, is an alcohol. It just means it's got OH stuck on it. The OH group is called a hydroxyl group. It's not called hydroxide anymore because it's added on to this. So it's got the YL ending, just like our methyl, ethyl, propyl, so on. So a hydroxyl group, OH added on to a hydrocarbon gives us an alcohol. And this is all that alcohol that you might, like beer, wine, and liquor. That's this. It's based on ethanol. There's ethane with a alcohol group on it. That's the basis for almost every kind of alcohol in the world. Okay? And it's ethanol. Number 2, in ether. Ether, you might recognize the word by its association with medical or dental things. In about 100 years ago, 50 years ago, they used to knock people out with ether. Okay, they take a little cloth. You might have seen an old spy movie or a detective movie or a crime movie where somebody took something and put some liquid on a cloth and put it over their face and made them pass out. That's an ether. Okay, there's better ways of doing it now called just not calisthenics. Yeah, that make people fall asleep. Okay. Yeah, anyways, the branch of medicine that deals with putting people to sleep. Yeah, anesthesia. There we go. So this is one of the early anesthetics or anesthesiologists' tools, and it's an ether. It's basically, notice, by the way, oxygen in all these. So anytime you see an oxygen, you should raise a red flag. That's a different functional group. And an ether is 2 different groups. So it could be methyl ethyl ether. It could be methyl propyl ether, methyl butyl ether. It could be butyl pentyl ether. Okay, so stick 2 groups on the sides of an oxygen, and you have an ether. Now, the next 3 or 4 are very similar. So it's a little bit tricky, but you need to be careful. So that's why it's going to take you a little bit of time tonight to study. C double bond O, C double bond O, C double bond O, C double bond O. So that's going to be one of these 4. The simplest one is the ketone, right here. Ketone is just a simple double bonded oxygen stuck on the side of this. Okay? So change this over here to a double bonded O. And now I have a ketone. It can be in the middle. It can be at the end. No, it can't be at the end because that's going to make it something different. Sorry. It will definitely be in the middle. Double bonded oxygen off to the side. And I have a ketone. Lots of ketones are used in industry. One of the very common ones is called methyl ethyl ketone, or MEK. You can buy that at Home Depot in a can, in a quart can. It's used to clean the grease off of automotive parts. And that's what shops that work on your car use to degrease the parts if they're rebuilding your engine or rebuilding your transmission. A ketone, again, just an R. R here represents any hydrocarbon. R prime represents another hydrocarbon. Could be the same one or a different one. And so if I put methyl here and ethyl here, I get methyl ethyl ketone. Now the proper way to name those, completely different. You see these ones end in anone, O-N-E, like ketone ends in O-N-E. But I'm not going to ask you to name them. You don't need to know that, just for your information. The third one is sometimes called a carboxylic, and I want you to write that down instead of organic. They can be called both, it's true, but a lot of textbooks and chemistry calls them carboxylic acids. It comes from a carboxyl group, which is C double bond OO. Sometimes you'll see this written if you're reading package containers on foods, or reading a label that says something, it's got a big long name, and then it's got COOH. Guess what that is? It's not a coo. It's not what a hummingbird says. Not what a pigeon says. Coo, coo, right? Okay. It's a C double bonded O and an OH. Now this one has to be what we call a terminal group. You'll see this one and the one up here are terminal because there's an H at the end, and that means it has to end here. There's no second functional group. So if I take this, okay, and put this over here, we would have a carboxylic acid. And it's an acid because this hydrogen is going to be donated. Remember the definition of an acid is a proton donor. And so the H is donated. This oxygen you would think might be given up and it form a base, but it doesn't because of the structure here with the double bond. This is a very strong bond right here, and the OH bond is the weakest link. So it's going to give up that H and form an acid. I'll have this with a negative charge and a hydrogen floating over there as a positive charge, just like our acids and bases do. So carboxylic acids do form acids. Their name is always going to have the name acid in it. Sally?
Would it drop the hydrogen on top or would it keep it?
You're right. I got too many. Nice. Okay, the fourth one is, and the fifth one here, aldehydes and esters. Okay, so let's talk about ester. Just like the Bible book, except it's not capitalized, same name, okay? And so it looks like a carboxylic acid, but what's it missing? It's missing the H, okay? So there is a strong relationship between these two. Again, in chemistry, you can change carboxylic acids into esters and back and forth very easily in what's called, the book actually covers it later in the chapter, a hydration, dehydration, hydrolysis reaction, I can't remember. But we get rid of that hydrogen there and we have a ester group. So ester is basically carboxylic acid minus the H. And an aldehyde is basically a carboxylic acid minus the O that was there here. Okay, so this one's aldehyde. These ones are going to be a whole different family of compounds. They end in AL instead of ANE. Okay, so these will all be, this one will be butanal. If I did this, C double bond O and just put an H here, it's no longer butane, it's no longer butanoic acid, now it's butanal. And again, we could spend a couple more weeks naming these things and all the rules for naming them, but I'm not going to, okay? So, we've got these four, that's going to be your biggest challenge, okay? C double OH acid, C double bond O ketone, and then you get the two variations. Figure those out. The only other one you need to know is if you see nitrogen, everybody see nitrogen, it's amine, A-M-I-N-E. And the ending is always going to be amine. So nitrogen, amine. I'm not making you learn this one down here because I don't want to confuse you more than you already are. Okay, amine, nitrogen. It's got an N in it. The fourth letter is N, A-M-I-N-E. I don't know if that helps. Lots of these other things have N in them as well, so don't just go by that. Any questions here? These are 7 functional groups. Then there's dozens of others that are less common. These are the most 7 common ones that you will see if you go and study microbiology, or if you go and study pharmacology, or if you go into organic chemistry, one of the branches of chemistry that deals more with living things. You'll see lots of these. These occur in plants, they occur in animals, they occur in your body, they occur in the foods that we eat and drink. Sometimes you'll see ketones in some of the fruits that we eat. Anything that ends in ONE is going to be a ketone. Anything that ends in OL is going to be an alcohol. So as you read labels, just say, I think I know what that is. Okay? Okay, that makes us caught up. Let's take a minute and talk about this. That's my reminder. Let's get my picture up here. There we go. Yay. What is this? Read. Hexane, good. And it would have two hydrogens on each one of these, right? And I'm drawing like this. I never sort of point them in because hexane is this. I'm going to pass it around. It's a really cool structure. I love hexane. It's so perfect to me. It's elegant, perfectly symmetrical, looks like a wheel. The wheel keeps on turning. And so on. And so this is hexane, right? Everybody sees, if I put a methyl group on here, methyl hexane. Put another methyl group on here, I got what? Dimethylhexane. Put a methyl here, I got 1,2-dimethylhexane. Put a methyl here, I got 1,3-dimethylhexane, 1,4-dimethylhexane, and so on. So these things, you could load it up with all kinds of cool stuff. Taylor?
Why wouldn't it be cyclohexane?
Yeah, it is. Didn't we say that? Yeah, he said that.
No, I said
Sorry,
Hexane, not
I just wanted to
Cyclo.
make sure.
Cyclo. Insert cyclo 82 times in my last conversation. Last minute. Okay. Cyclohexane. Now, what happens if I put some double bonds in here? Read.
Would it be cyclo tri? No. Cyclo hex tri.
Yeah, actually, you're really close. It'd be 135 cyclotriene is how it goes, but you don't need to know that, okay? And that's a mouthful, and I don't want you to know that. So instead, we call it benzene. Yeah, okay? So if you see something like this, this is a benzene, or benzene ring, sometimes it's called. It has the formula, since I added 3 double bonds here, I lose some hydrogens, right? So I've got 2 extra electrons here, 2 extra electrons here, 2 extra electrons here. So I actually lose 6 hydrogens to make these 3 double bonds. So guess what? 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here. And look what this comes out to be. Ooh, Ferris wheel. Isn't that cool? Isn't that beautiful? We'll pass him around too. So this is benzene. Benzene does an amazing number of things in living things. And that's the reason I need to bring it up here. Okay, we're just going to spend about 3 minutes on it. Benzene, with its 3 double bonds, doesn't really have 3 double bonds. Who remembers the word from early this year? Resonance structures. When we drew polyatomic ions using Lewis diagrams, I remember sometimes we drew SO3 like this. Sometimes we drew SO3 like this. Sometimes we drew SO3 like this. And we said, hey, whoops, what's the deal? Which one's right? All 3 of them are right. We put them all in a big bracket and said those are resonance structures. It's a good review for next week's exam, huh? And so resonance structures mean there's a equal probability that those electrons are here, here, or here. And so what they really do is they spend 1/3 of their time in each of those locations, and the same thing happens here. So instead of 2 electrons here and 2 bonds here and 1 bond here, what really happens in benzene that makes it so special is these 6 electrons, 2, 4, 6 from the double bonds, they swirl around. They spend an equal amount of time on all of those carbons. So sometimes you'll see benzene drawn like this, and sometimes you'll see it drawn like this. Ta-da! So in your notes, make sure you draw it both ways. Benzene can be drawn with 3 double bonds at the 1, 3, and 5 positions, or it can be drawn with a circle in the middle. This is much more common in today's world, but again, you'll see textbooks, and even our textbook has lots of benzene drawn with the, I think, the double bonds. Section 4 of chapter 21. Let me look it up real quick here. Seven who?
770.
Yeah, I had it open earlier. Yeah, there they are all. No, they got the circle. Good. Okay, so benzene, its formula is C6H6, and it looks like the one I'm passing around right there, the Ferris wheel one. Very cool. Now, because benzene and its derivatives, the word derivative means things that are made out of this. Okay? So one of the common structures made from benzene is this one. Got 2 of them together, and that's the foundation for what we call mothballs. Anybody know mothballs? Yeah, stinky things we put in the closet to keep the bugs out so they don't eat all your cotton. And mothballs is something called naphthalene, N-A-P-H-T-H-A-L-E-N-E, that's naphthalene. but it's based on benzene. Since a lot of these compounds have a very strong smell, they are called aromatic hydrocarbons. Okay, so benzene is the foundation for aromatic hydrocarbons, cyclic hydrocarbons. So I want you to know that if you see aromatic hydrocarbons, it usually has to do with benzene or cyclohexane or something related to these. And it's definitely, it does a lot of things in the human body. If you look on page 771, 772, 773, you'll see a bunch of these things drawn. We're not going to teach you how to name them, but it's just like the other ones. Cyclobenzene. It would be, but we don't put cyclo, it's just benzene. Benzene implies that it's a circle, okay? So it would be methylbenzene. Ta-da! Dimethylbenzene. 1,3,5 trimethylbenzene. 1,3,5 trifluorobenzene, and so on. Okay? Everybody good? Okay, we've got about 23 minutes to review. Take a fresh page in your notebook and let's try a few questions here. Number 1 and 2, write your names down for these two compounds. Most of tomorrow's test is naming and drawing. Naming and drawing. Drawing and naming. Naming and drawing. Yes, sir.
Most complex things we use in our naming and drawing.
We'll show you one in a minute.
The alcohol.
No, I won't give you the alcohols. You don't have to.
We just have to know what they're.
What is it?
You need to be able to recognize them. Not what they do, just recognize. OH, alcohol. Double bond O by itself. Ketone. Okay, number 1, 2. Everybody write this down. Give you a minute to figure it out. And I'm going to drink some more water. You have a question?
Yes, are those two, so to speak, connected in the second problem?
Yeah, I just copied that straight off a sheet that I'm using. So remember earlier this week or last week we did something that looks like this: CH3, CH2, 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 CH3. Some books flip that around just because it doesn't matter if it's on the left or the right. Okay. Some books try to be more accurate and say, hey, that's not CH3, that's H3C. Give me a break, okay? Left to right. And then if it's on that side, it's going to be CH3. It's the same thing, guys. It's a methyl group. Okay, so don't panic if you see H3C. So this one is attached to that. It has to be, otherwise it's not floating by itself. Same thing, yeah. Stick a line in it. It has to be. Right? It's not floating by itself. Has to be a bond in there. It should be CH2, 2, 3. Yeah, there should be a 2 there, right? No. 1, 2, 3. Yeah, no, just 1. Yeah, Debski, that's enough. Okay. Name the first one, Eli.
3,4-dimethyl-1-butene.
Methyl 1 who?
Butene.
3,4-dimethyl 1-butene. Okay. Nice try, valiant effort. You forgot to find the longest chain. It's not 4. You have fallen for the oldest trick from 4 days ago. Okay? Who's going to correct? Savannah, you got it?
3-methylpentene.
3-methylpentene. So let's draw a circle around our longest chain. Okay? So don't fall for this one. It can be a U shape, it can be a Z shape, it can be some really weird shape. Find the longest continuous, which means connected, chain. So we definitely have a pent. And it's definitely an ENE because of the double bond. And I can put a 1 in, you don't need to. You put this 1 here, but you don't need it if it's in the first position. Okay, and Savannah, what was that? The rest of it?
3-methylpentene.
Good, so here's my methyl group, 3-methyl. Done. We always start numbering from the end that has the double or triple bond closest to it. If there's no double or triple bond, I'm going to number from the end that's closest to whatever's attached to it. But if there's a double or triple bond, we start from the end where the double or triple bond is closest to. Okay, second one, Colby.
4-ethyl 5-methyl hexane. 2-hexane.
Nice. Okay, 4-ethyl 5-methyl. The number 4 to show me where the triple bond is. Then hex. Oh yeah, 2. Hexine. Okay, everybody see it? Please ask questions if you don't. No, you could swap these around. You can put the 5-methyl 4-ethyl, but what you can't do is call it 2-methyl 3-ethyl. That would be wrong because we have to start from this end because of the triple bond. Okay. No, I'm not gonna force the alphabetical. Questions on these two?
Wait, so ethyl will come first because it's first in the.
If you were going to alphabetize them?
No, if we were just. What did you just say that you have to do?
So you didn't have to do anything. What's your question? I said if you swap these two around, it's still true if I had 5-methyl 4-ethyl.
Okay. No, if you just don't swap the names, no.
Usually I'll just start, if I have 2 of them, I just usually start, either way is fine. Okay, save this for later. Do that one right there. James, you ready for this one?
2-methyl 3-ethyl pentane.
Good. Nice and straightforward. 2-methyl 3-ethyl pentane.
I love this. I figured it out today. Yeah.
Okay, what's that called, Lainey?
Hexane? No, I don't know. Non-name? Psycho?
Psycho. That's a psychononane.
Cyclo?
Good. Cyclononane. If I don't put anything on it. What was that? Okay, have some fun with this. Okay, first question is where do you start? Okay, and here's the answer. Find what you would consider, and before you start working on it, let's all get on the same page. What would be the most important or have the greatest effect on this molecule? In other words, what's going to dominate its behavior? It's like having the biggest guy on the playground when you were a little kid. He's the guy that, was a bully or controlled things. Or what is the biggest truck in the parking lot gets that parking spot, right? So the biggest thing here is usually going to control the numbering here. What will we choose? That says propane, so yes. So this is going to be my number 1. I'll give you that, okay? propyl is going to be my number one position because it is all of your alkyl groups, methyl, ethyl, propyl, and so on, take priority over the halogens. Unless there's no alkyl groups, and then the halogens, you can start anyway. Give you a minute to work on that one. Should take up a good chunk of paper. It's long, but it's really not that difficult once you figure it out, right? Just name them and number them. Do, and bromo later on. Okay. Other than that, looks good. So don't forget your O endings on any of your halogens. Okay.
Yeah.
Savvy, what you got? You got this one done?
Is it one propyl, two iodo,
Yeah, louder please. 1 propyl, 2 iodo.
4 methyl, 5 bromo, and then 6 ethyl, 7 chloro.
Good. Okay, everybody got it? So it's 1 propyl, 2 iodo, 4 methyl, 5 bromo, 6 ethyl, 7 fluoro.
Do you have the cyclo?
Cyclo, no name. Cyclo. Cyclo. Yes.
Okay, I have a question.
Yes.
Somebody was talking about recycle something. What is that? Like recycle.
Plastics. That's a good thing to do. You should recycle your plastics. I do. Every Saturday. This is my run to the recycling place.
Like they were talking about it was on like the regulars test, and then Taylor Rollerson like agreed.
The word recycling, as far as I know, doesn't appear on anything.
Okay. Okay.
It appears on that sheet with the plastics, because those are the recycling symbols. Oh, it might be on there because it has a recycling symbol on it. You don't need to know those though. Like code 2 is polypropylene. It isn't. I don't know them, so no. Okay. How about if I put one more thing on here? Let's change color. What would this do? Read.
You would just, you would go the other way around since those. I think you would because it's the shortest distance between,
If this ever showed up on a test, I have a lot of grace on this one. Give me a shot, Lorna.
No, I'm just kidding. I probably
Okay, in other words, which way do we go? Do we still go clockwise or do we go counterclockwise? And so if I go clockwise, it's 1, 2, 4. If I go counterclockwise, it's 1, 2, 4. And again, now we get down to a question of these are both halogens. This one is an alkyl group and this one's a halogen. So in theory, this one would still take priority and we'd still go clockwise. Again, I wouldn't be real picky on that, and I don't have anything like that on the test that I know of. Okay. Let's do a few more here. Let me wipe this off. Whoops. Let's go. Oh, we just did that one. Yeah, okay, draw these. 3 to draw. Draw some diagrams for me. You don't have to put all the hydrogens in, but you definitely need to show me all the carbons. Anybody want to draw one? Reed, sideboard, Savvy, up here. You doing the first one, Reed?
I'll
Okay, Savvy, second one maybe? Do the third one. John Griffin? You can, right?
Yeah, third one?
Yeah, third one. Left side of the board right there. You got a marker?
Which
There's
board?
two black markers there, huh?
Where do you want me to?
Anywhere. It's pretty wide open.
Oh, yeah.
There you go. Okay. Read over here. We got 2,3,3 trimethyl butane. Butane? Butane. Lauren, question?
Why would you not name that one 223?
2,2,3. It is. Oh, I thought we already fixed that. We fixed that like fourth period. It should be 2,2,3. Good idea. So that's, I actually copied that off of something wrong. So 2,2,3. What it should be there. Do that. Right. Because the numbers have to be small. This is 2,2,3. It says 2,3. Okay. So it's the same compound, but we're numbering from the end that gives us the smallest three numbers. If I have a choice between 2,3,3 and 2,2,3, 2,2,3 is overall small. Here, the third one, 3-ethyl, 2,2-dimethyl hexane. Got it. Over here, no name, 1, 2, 3, 4, 5, 6, 7, 8, 9, with the methyl group on the second one, 2-methyl, no name. Good job, Savvy. Good job, JG. And Reed. Okay? I want to do stop. Oh, take your textbook real quick before we do more of this. Textbook, page 777, please. Let's just make a quick terminology study guide. So you can either check these off in your textbook or make a list real quick and make sure you know them for tomorrow. This is what we have covered as far as vocabulary. Okay, so these are your classic true-false questions, multiple choice questions. In section 21.1, we have covered fractional distillation, hydrocarbons, organic compounds, saturated and unsaturated. So we did a real good job in section 1. We covered most of that. The only thing you can omit is cracking. You don't need to know what that is unless you want to go study petroleum engineering someday. In section 2, we have talked about alkanes, cyclic hydrocarbons, cycloalkanes, and the word parent chain is simply what I've been referring to as the longest chain. Okay, the parent chain is the longest chain. We stick little pieces onto the sides of the parent chain. So I don't think I use that term, but it's obvious. Section 21.3, alkenes and alkynes. And you should know that they are unsaturated and what they are, and how to name those things. Section 21.4, the only words here that you are responsible for is isomer and structural isomer. There are other kinds of isomers, as you see listed there, which we're not covering in this class. But again, if you take a further chemistry class in organic chemistry, you will learn all about optical and stereoisomers and other things. And in section 5, you're responsible now for the word aromatic, which we just covered a few minutes ago. Okay? So those are the terms from the chapter. Review those tonight. Review your naming and drawing and writing formulas, and you should be in good shape. Turn the page, if you still got your book over, turn to 772, and I'll show you those aromatic compounds. Here's, in the top left, you see a picture of mothballs called naphthalene. Okay, evidently anthracene next to it is used in paints, and underneath it, phenanthrene is produced by burning coal, it looks like, and p-xylene, you'll see this in clothing and stuff. Okay, so there's lots of cool stuff made out of benzene, aromatic hydrocarbons. Okay, let's see if we got one or two more practice problems in here. I don't remember. Let's do this. Who wants to tell me the formula for methylnonane over here? What would the empirical formula for methylnonane be? I'm looking for a C sub something, H sub something. What are the two numbers? That's the empirical formula for this one. John Griffin?
C10, H22.
Perfect. How'd you do that? It's way over there.
Carbons, and then multiply 2, and now 2.
Okay, so there's no double bonds, there's no triple bonds. He says if there's 10 carbons, 9 in the long chain and 1 for the methyl. When I write the formula, I have to include everything, right? So 10 carbons, 2 times 10 plus 2. He remembers the formula from the other day. How about if I look at, cyclopentene here? Here's our house upside down. Cyclopentene. No cyclos. No, don't use formulas on cyclos. They don't follow the rule because they lose. Cyclo. There you go. Where's my double? Yeah, there's my double. Okay, let's take these two. What would the formula be for number 2 down here? C something, H something. Now you can add them all up. If you can't remember the formulas, draw the picture and add them all up. So you got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. Okay, but then you need to be very careful about how many bonds. Like this carbon here, he's got a triple bond and a single bond to carbons, so no hydrogens. But if we remember that every time we go from a single to a double bond, we lose 2 hydrogens, and we go from a double to a triple bond, we lose 2 more, then if I count the number of carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, C9, and it's going to be 18 minus 2. 16 is what you should get. Okay? Because we lose 2 hydrogens for every bond we make, because each hydrogen brings an electron. So 2 hydrogens to go to a double bond. That's why this goes from +2 to +nothing. And then we lose, to go to the triple bond, we lose 2 more hydrogens. Go from +nothing to -2. So the formula for this one up here, C 1, 2, 3, 4, 5, 6. Lauren?
Will there ever be like more than one double bond or more than one triple bond?
In real life, yes. In my class, no.
Okay.
There's some really funky rules about naming those words. All kinds of numbers, and dienes and ditribeneines. What's this going to be? C6H, 1 double bond, 12. Yep. And really, we can put side groups on here and it's still going to hold true. As long as it's only got 1 double bond, CX, H to the 2X. And if it's got a triple bond, 2X minus 2. None of those, 2X plus 2. I think we're in good shape. I will post this video tonight if anyone wants to rewatch it. Period 3. This is for you and everybody else.